Hello students, welcome back. So we are doing laws of indices from icse class 9 textbook, isn't it? Exercise 7c. And in our previous videos, we have completed till question number 12, and today we'll start from question number 13 onward and we'll complete this chapter today, okay? So let's begin. So this is question number 13, and this is the expression given to us and we are asked to evaluate. Evaluate means we are asked to find the value of this expression, okay? Simplest value of this expression. So let's do this. So this 2 to the power n we write as it is into, now 6 we convert into 2 into 3, okay? 2 into 3, 2 3s are 6, isn't it? Whole to the power m plus 1 into 10 means 2 5s are 10, 2 into 5 means 10, whole to the power m minus n into, this is 15 means 3 5s are 15, isn't it? So 3 into 5 whole to the power m plus n minus 2. The power of 15 is m plus n minus 2, and this is 15, 3 5s are 15, okay? So whole upon, in the denominator we have 4 to the power m means 2 to the power 2m, because 2 squared is 4, this 4 is 2 squared, and this m is here m, okay? So 2 to the power 2m, 4 to the power m means 2 to the power 2m, 2 squared means 4, okay? Into 3 to the power 2m plus n into, this is 25, isn't it? So 25 is 5 squared, 5 squared is 25, 5 squared is 25, so m minus 1 comes here, m minus 1, isn't it? 5 squared is 25, okay? So m minus 1 was already there, we got m minus 1. This means 5 to the power 2 into m, 2m plus into minus, 2 1s are 2, 5 to the power 2m minus 2, okay? So instead of this we write 5 to the power 2m minus 2, 5 squared, 2 into m is 2m minus 2 1s are 2. Now we write this power separately to both the numbers 2 and 3, okay? Because both the numbers 2 and 3 are within the bracket, and this is the power for both of these numbers, so we have to write this power individually to both the numbers now, okay? So 2 to the power n into 2 to the power m plus 1 into 3 to the power m plus 1 into, here also the same thing, m minus n, the power is for both the numbers, so we put the power individually. 2 to the power m minus n into 5 to the power m minus n into, same thing here, this power is for both the numbers 3 and 5, so 3 to the power m plus n minus 2 into 5 to the power m plus n minus 2, okay? Whole upon, we have 2 to the power 2m into 3 to the power 2m plus n, isn't it? 2m plus n, okay, into 5 to the power 2m minus 2. Now what we do is we add up the powers of the numbers having same base, okay? This 2, 2, 2, all this number are having equal base, isn't it? This is 2, this is also 2, and this is also 2, and there is multiplication sign in between them, isn't it? So we can add the powers. When the bases are equal and they are being multiplied, the powers should be added. So we add up the base powers, okay? So let me start from here. 2 to the power this n plus this m plus 1 plus, here we have m minus n. Now we don't have any 2 here, so we have 2 to the power 2m in the denominator, so we bring this number to the numerator, the sign of the power changes to minus, isn't it? So minus 2m, okay, into, now we write 3. Okay, since this 3 and this 3 equal base, isn't it? So their power should be added. 3 to the power m plus 1 plus m plus n minus 2, isn't it? M plus n minus 2, and after that we don't have any 3 now. We have 3 here in the denominator, so we bring this 3 to the numerator, the sign of the power changes to minus. Okay, this plus 2m becomes minus 2m, and this plus n becomes minus n. Now comes 5, isn't it? 5 into 5 to the power, here we have m minus n, here we have m plus n minus 2, same base, that means we must add up the power. 5 to the power m minus n, okay, plus m plus n minus 2. Now we have this 5 in the denominator, we bring this number to the numerator, the sign of the power changes to, this plus 2m becomes minus 2m, this minus 2 becomes plus 2. Okay, plus 2m becomes minus 2m, and this minus 2 becomes plus 2. So we don't have any number in the denominator now, because we transpose this number to the numerators. Okay, so now we have plus m, m and m, 2m, isn't it? So minus 2m, plus m, 2m minus 2m cancelled out. So minus n and plus n, you can see plus n here, no sign in front of n means plus n, so this plus n and minus n can be cancelled. So we have 1 remaining, isn't it? So 2 to the power 1 into, here we have plus n and minus n cancels out, m plus m, 2m and minus 2m, plus m plus 2m and minus 2m, so cancels out, plus 2m and minus 2m. So here we have minus 2 and plus 1, that means 3 to the power minus 1, isn't it? Minus 2 plus 1, opposite sign we must subtract, 2 minus 1 is 1, sign of greater number comes, that is minus, into, here we have plus m, plus 2m and minus 2m, so this can be cancelled. Okay, plus m, plus 2m and minus 2m can be cancelled, minus n and plus n can be cancelled, minus 2 and plus 2 can be cancelled. So nothing is left in the power there, so we write 5 to the power 0. Okay, so let me continue here. 2 to the power 1 means 2, isn't it? Any number when the power is not mentioned, we must understand the power is 1. So 2 to the power means 2 to the power 1 means 2. Okay, into 3 to the power minus 1. So this can be taken to the denominator, 1 upon 3 to the power 1. 3 to the power 1 minus 1 becomes plus 1. Power 3 to the power minus 1 becomes 3 to the power plus 1 when we take this number to the denominator. Sign of the power changes, isn't it? So this becomes plus 1. Okay, into 5 to the power 0. 5 to the power 0 means 1, because any number raised to power 0 is always 1. Okay, x to the power 0, 1, 100 to the power 0, 1, 1 to the power 0, 1, but 0 to the power 0 undefined. Okay, except 0, 0 should be kept as exceptional case. This is exceptional case. 0 to the power 0 is not 1, except 0, any number raised to power 0 is always 1. We must keep this in mind. So 5 to the power 0 means 1. 5 to the power 0 means 1. Okay, so we have in the numerator 2 into 1 is 2, into 1 is 2, and in the denominator 3 to the power 1 means 3. So the answer is 2 upon 3. Okay, this is a proper fraction because the number in the denominator is greater than the numerator, so we don't have to convert this into mixed fraction. Okay, so this is the answer for this question number 13. The simplest value is 2 upon 3. Okay, now let's do question number 14. We are asked to evaluate. Evaluate means we are asked to simplify this. Okay, we are asked to find the simplest value of this expression. So let's do this. So here we have x to the power q upon x to the power r whole to the power 1 upon qr, isn't it? So bases are equal, x and x. That means this power, when we take to the numerator, becomes minus r. So x to the power, you can write this as x to the power q minus r, isn't it, into 1 upon qr. Okay, this q minus r is in the numerator and this qr is in the denominator. Okay, suppose if I write 2, we must understand this number is in the numerator. Unless there is a number mentioned in the denominator like this, we must understand this is in the numerator. Okay, if there is already a number mentioned like this, then we should say there is 3 in the denominator. Otherwise, this number is in the numerator and the number in the denominator is 1. Okay, so into x to the power, this is r and this is p. Both the bases are equal, x and x, so this becomes r minus p whole to the power 1 upon rp, isn't it, into x, bases are equal, so this power should be subtracted, isn't it, x to the power p minus q whole to the power 1 upon pq. So as I told you earlier, this number is in the numerator and this is in the denominator. So you can write this as x to the power q minus r into 1 is q minus r whole upon qr, okay, into x to the power r minus p into 1. This number is in the numerator. Okay, r minus p into 1 is r minus p whole upon rp into x to the power p minus q into 1 p minus q upon pq. Now since x bases are equal and there is a multiplication sign in between them, so we must add up the power, isn't it? So x to the power q minus r upon qr plus r minus p upon rp plus p minus q upon pq. So since the bases are equal, their power should be added, isn't it? So x to the power, now since this and this are fractional numbers, isn't it, so we must take the LCM of the denominators to add these fractional numbers, isn't it? So let's take the LCM of this number qr, rp and pq. The LCM will be pqr. Okay, pqr. Here we have qr, here we have rp, here we have pq, isn't it? Here we don't have p, here we don't have q, here we don't have r. So let's take the LCM qr into rp into pq, isn't it? So when we take the LCM, suppose we start with q, q1s are q, now this r comes here, this r comes here, this p comes here, this p comes here, and q1s are q, q1s are q. Now we start with r, this one comes here, r1s are r, r1s are r, now p, and this one comes here. Now we do with p, this one we bring down, this one, p1s are p, p1s are p, and this one. So the LCM will be q into r into p, that is pqr. LCM will be pqr. So qr into which number is pqr? Qr into p is pqr, isn't it? So that p into q minus r, isn't it? In other way, you can think in this way also. Qr means you don't have p here, isn't it? You don't have p here because we have pqr. We don't have p here, so that p into q minus r, that is pq minus pr. Okay, qr into p is pqr, so that p into q is pq minus p into r is pr. Now this plus sign comes here. rp into q, we don't have q here, so rp into q is pqr, rp into q is pqr, so that q into r minus p, q into r, qr minus q into p, qp or pq, same thing, okay, plus we don't have r here, isn't it? So pq into r, we will get pqr, pq into r, we get pqr, so that r into p, pr minus r into q, qr, okay. So or x plus pq minus pq cancels out, minus pr plus pr cancels out, plus qr minus qr cancels out. So 0 upon pqr, isn't it? X to the power 0 upon pqr. Now we know that any number whose numerator is 0 is always a 0, isn't it? What I mean to say by that is, if a number is 0 in the numerator and there is any number, suppose x, the value will be 0, okay. If the number in the numerator is if the number in the numerator is 0 and there is 1 million or 1 trillion in the denominator, then also the value will be 0, okay. When the number in the numerator is 0, whatever be the number in the denominator, that doesn't matter, the answer will be straight away 0, okay. But there should not be 0 in the denominator, please keep this in mind. Any number except any number but except 0, except, okay, except 0. 0 upon any number except 0 is always 0. 0 upon any number in the denominator except 0, okay, because 0 upon 0 is not equal to 0. 0 upon 0 is not equal to 0. 0 upon 0 is undefined. Please keep this in mind. 0 upon 0 is undefined. So 0 upon any number except 0 is always 0. I hope you got this. Please take note of this in your exercise copy and remember this, okay. So 0 upon pqr is, this pqr is a non-zero number, so 0 upon pqr is 0. So this gives us x to the power 0. So x to the power 0 means 1. Any number raised to power 0 is 1. Any number raised to power 0 is 1, okay. Here also exceptional case, except 0 raised to power 0, raised to power 0. I hope you got this. Except 0 raised to power 0 means 0 to the power 0 is not equal to 1. 0 to the power 0 is undefined, okay. 0 to the power 0 is undefined. Please keep this in mind. 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is 1. So x to the power 0 is definitely 1. So the value of this expression, we were asked to find the value of this expression. The value of this expression is 1, okay. So this is the answer. I hope you got this. Now let's move on to the next question. Let's do question number 15. Question number 1 of 15, okay. Prove that. So we are asked to prove this equals to 2b square upon b square minus a square. We have these numbers in the left hand side and we are asked to prove this equals to this, okay. So let's take left hand side. LHS equals to a to the power minus 1 upon a to the power minus 1 plus b to the power minus 1 plus a to the power minus 1 upon a to the power minus 1 minus b to the power minus 1. So this is what we have in the left hand side, isn't it? So we know that if we have a to the power minus 1, we can bring this number to the, because there is always 1 in the denominator, isn't it? So we can bring this number to the denominator and the sign of the power changes to a to the power plus 1, okay. So a to the power minus 1 becomes a to the power plus 1 if we bring this number down to the denominator. Now every number has power 1, so we don't have to mention power 1, okay. Suppose we have a to the power minus 2, we can write this as 1 upon a to the power plus 2. A to the power minus 2 can be written as 1 upon a to the power plus 2. when we take the number from the denominator to the numerator or from numerator to the denominator, the sign of the power changes to minus or plus. Okay, if the number is plus, it changes to minus. If the number is minus, it changes to plus. Okay, so we do the same thing here. We have 8 to the power minus 1. This means 1 upon a, isn't it? 1 upon a to the power plus 1. So we don't write plus 1, because if we write 2, we must understand the power of this number is plus 1. Okay, so we don't write this power 1. If we write 5, we must understand the power of this number is plus 1. Unless another power is mentioned like minus 2 or plus 2, if the power is already mentioned, then it's okay, we will do with that. But if the power is not mentioned, we must understand the power is plus 1. Okay, so a to the power minus 1, this number a to the power minus 1, I can write a to the power 1 upon a to the power plus 1. 1 upon a to the power plus 1 means a to the power 1 upon a. Okay, we don't write power plus 1. So this is 1 upon a plus this is 1 upon b. Power plus 1 we don't write. Okay, so plus this is 1 upon a whole upon this is 1 upon a minus 1 upon b, isn't it? A to the power minus 1 means 1 upon a, minus comes here, b to the power minus 1 means 1 upon b. Now we have 1 upon a in the numerator, we copy as it is. In the denominator we take the LCM of a and b. LCM will be ab. So a into b is ab, so b into 1 is b, plus b into a is ab, so a into 1 is a, plus this 1 upon a we write as it is, 1 upon a whole upon this is a. Okay, whole upon we take the LCM of a and b. The LCM will be ab, isn't it? So a into b is ab, so b into 1 is b, minus this minus sign comes here, b into a is ab, so a into 1 is a. Now let me continue here. Now what we do is 1 upon a we write as it is, we put into sign, then this ab from the denominator goes to the numerator, ab upon b plus a comes down to the denominator, b plus a. Okay, this is b, this ab goes to the numerator, ab, and b plus a comes down to the denominator. This plus sign comes here. Okay, now 1 upon a we write here as it is, 1 upon a into this ab as usual goes to the numerator, ab upon this is b minus a, isn't it? So b minus a. Now this a and this a can be cancelled, this a and this a can be cancelled. So we have 1 into b is b upon b plus a, plus 1 into b is b upon b minus a, isn't it? Now again these two are the fractional numbers. We must take the LCM of the denominators to add them, isn't it? We must take the LCM of the denominators to add these fractional numbers. So b plus a into b minus a, we know the formula, a minus b into a plus b equals to a square minus b square, isn't it? So b plus a into b minus a is b square minus a square, isn't it? When we multiply these two numbers we get this, a plus b into a minus b is a square minus b square, so b plus a into b minus a is b square minus a square. Now b plus a into b minus a gives us this means b minus a into b, isn't it? So b into b, b square, plus into minus, minus b into a, ab, plus comes here, b minus a into b plus a gives us this number, so b plus a into b, isn't it? So b into b, b square, plus into plus, plus b into a, ab. Now this minus ab and plus ab can be cancelled, plus ab minus ab can be cancelled. So this is plus b square, that is 2b square, and in the denominator we have b square minus a square. b square minus a square, isn't it? So this is what we have in the right hand side, hence proved. This equals to RHS. Okay, so this is proved. I hope you got this. Now let's move on to the next question. Okay, now let's do question number 2 of 15. Prove that this equals to ABC. We are asked to prove this expression equals to ABC. Okay, so let's copy the left hand side of this equation first. LHS equals to a plus b plus c whole upon a to the power minus 1, b to the power minus 1 plus b to the power minus 1, c to the power minus 1 plus c to the power minus 1, a to the power minus 1, isn't it? So this is what we have in the left hand side. We are asked to use this and prove this equals to ABC. So as I told you earlier, suppose we have a to the power minus 2, we can write this as 1 upon a square. The sign of the power changes to plus 2 here if we take the number down to the denominator. Okay, similarly, if we have a to the power minus 1, this becomes 1 upon a to the power plus 1. Minus 1 becomes plus 1, isn't it? Power, sign of the power changes to opposite sign. If the sign is minus, becomes plus. If the sign is plus, becomes minus. So when the power is 1, we don't write the power 1 because every number has power 1 when the power is not mentioned. Okay, if I write 2, we must understand that this number has power plus 1. Okay, if I write 100, we must understand that this number has power plus 1. If I write x, this number has power plus 1. Okay, if the power is not given, then we must understand the power is plus 1. So what we do is we copy the numerator as it is, a plus b plus c, and in the denominator a to the power minus 1, b to the power minus 1. We take both the numbers to the denominator, 1 upon ab, isn't it? 1 upon ab. This a to the power minus 1 becomes a to the power plus 1, b to the power plus 1. Since every number has power plus 1, we don't have to write this. So this also becomes b to the power minus 1, c to the power minus 1 becomes 1 upon bc, b to the power plus 1, c to the power plus 1. Okay, plus 1 upon ca. I hope you got this now. Now we have a plus b plus c in the numerator. We write as it is, a plus b plus c, and in the denominator we take the LCM of the denominators. Okay, because this is a fractional number, this is a fractional number, this is a fractional number, and we are adding the fractional number, means we must take the LCM of the denominators. So LCM of the denominators will be ab, bc, ca will be abc, as we did this type of question earlier, isn't it? So let's take here ab, bc and ca. I'm doing this to make you understand. Okay, so first we do with a into 1 is a. Now b comes down as it is, this b comes down as it is, c comes down as it is, this c comes down as it is. So a into 1 is a. Now with b we will try this 1, b1s are b, b1s are b, the c comes down, this 1 also comes down as it is. So c 1 1 1, c1s are c, c1s are c 1. So LCM will be a into b into c into 1 into 1 into 1 into 1 into 1 into 1, isn't it? That is ABC. LCM is ABC. So AB into C is ABC. AB into C is ABC. So that C into this one is C plus BC into A is ABC, because we don't have A here. BC into A is ABC. That A into 1 is A plus CA into B is ABC, so B into 1 is B. So let me continue this here. Now we have A plus B plus C in the numerator. We write as it is, A plus B plus C into ABC goes to the numerator, isn't it? ABC upon this number comes down to the denominator. C plus A plus B plus C plus A plus B means A plus B plus C. We can write this because we have not changed their sign. Okay, this C has plus sign, so C has plus sign, B has plus sign, B has plus sign, A has plus sign, so A has plus sign. We cannot change their sign Okay, we can rearrange the number. I mean to say 2 plus 3 plus 4 equals to 9, isn't it? 4 plus 3, 7, 8, 9. So 3 plus 4 plus 2 equals to 9, or 3 plus 2 plus 4 plus 4 is also equals to 9. Whichever way you arrange the number and add, the result will be 9, isn't it? That means it doesn't matter where you keep A or where you keep B or where you keep C, but their signs should not be changed. Suppose we have plus 4 here, we cannot write minus 4 here. Okay, if we do this, the result will change. So result should not be changed. Now we have A plus B plus C in the numerator and A plus B plus C in the denominator, so we can cancel this number because there is into sign. Now we have ABC remaining, isn't it? So this is ABC. ABC is in the right hand side, hence proved, equals to RHS. I hope you got this. Now let's move on to the next question. Okay, now let's do the last question, question number 16 of exercise 7C, and this is the last question of this exercise and the last question of the chapter laws of indices, that is chapter 7. Okay, so let's do this. So we are asked to evaluate means we are asked to find the simplest value of this expression. Okay, now what we do is we have 4 upon 216 whole to the power minus 2 upon 3, isn't it? So we write 4 into, we bring this number 216 to the numerator, 216 216, isn't it? The power minus 2 upon 3 becomes plus 2 upon 3 plus 1 upon this, isn't it? So we bring this number to the numerator, 256 whole to the power, this minus 3 upon 4 becomes plus 3 upon 4 plus 2 into this 243 to the power minus 1 upon 5 becomes 243 to the power 1 upon 5. Okay, now this is 4 into 216. We will find the factors of 216. Okay, 216 means we'll start with 2. 2 1s are 2, 0, 2 8s are 16. 2 1s are 2. Now we have 1 here, so we cannot divide 1 by 2. We must take 2-digit number. So before taking 2-digit, we must introduce a 0 here. So 2 8s are 16. Okay. Now 2 5s are 10, 2 4s are 8, 2 2s are 4, 2 2s are 4, 2 7s are 14, 3 3s are 9, 3 1s are 3. 3 9s are 27, 3 3s are 9. Okay, so we have 2 into 2 into 2 into 3 into 3 into 3. This means 2 cubed into 3 cubed, isn't it? 1 2 3, 2 cubed, 1 2 3, 3 cubed. Okay, so 216 means 2 cubed into 3 cubed whole to the power 2 upon 3 plus 256. Now we will find the factors of 256. 256. 2 1s are 2, 2 2s are 4, 2 8s are 16, 2 6s are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4. 1 2 3 4 5 6 7 8. 2 to the power 8. 8 into 3 upon 4, isn't it? 256 means 2 to the power 8. 2 multiplied 8 times gives us this 256. 256 means 2 to the power 8. This 3 upon 4 remains as it is, plus this 2 into 243. 243. 3 8s are 24, 3 1s are 3, 3 2s are 6, 7 8, 3 7s are 21, 3 9s are 27, 3 3s are 9. 1 2 3 4 5. 3 to the power 5 into 1 upon 5. Now this is 4 into 2 cubed into 2 upon 3. Okay, now this 2 upon 3 power is for both the numbers 2 cube and 3 cube, so we apply this power to both the numbers individually. Okay, 2 cubed into 2 upon 3 into 3 cubed into 2 upon 3. This 2 upon 3 is for both the numbers, this, so we put this power to both the numbers, plus 4 1s are 4, 4 2s are 8, 2 to the power 2 3s are 6, 2 to the power 6, plus 2 into this 5 and 5 cancels out, so 2 into 3 to the power 1 means 3. Now 3 and 3 cancels out, 3 and 3 cancels out. Okay, so 2 squared means 4, isn't it? 2 squared means 4, so 4, okay, 4 into 2 squared means 4 into 3 squared means 9, plus 2 to the power 6. 2 to the power 6 means 64. 2 into 2 into 2 into 2 into 2 into 2. 1 2 3 4 5 6. 2 to the 4, 4 to the 8, 2 to the 4, 4 to the 8. 8 8 is 64. So 2 to the power 6 means 64, plus 2 3 is 6. Okay, so 4 4 is 16, 16 into 9, isn't it? 4 4 is 16, 16 into 9. So 9 6 is 54, 9 1 is 9, plus 5 14. 16 into 9. Okay, that is 144, plus 64 plus 6 is 70. Now we add up this because both are positive. 4 plus 0 4, 7 plus 4 11, 1, 1 plus 1 2, 214 is the answer for this question. Okay, so I hope you got this. This is the end of this chapter, exercise 7. Okay, I hope you got everything, the concept of laws of indices, and stay connected, stay tuned. Okay, I'll continue uploading more of the videos like this, and in the next video I'll upload the questions from logarithm chapter.